welcome to my channel Learn Math. In this session, we are going to find values of a and b in a given polynomial when x plus 1 and x minus 2 are factors of this given polynomial. So step 1 in performing synthetic division is to write the given polynomial in standard form. P of x is equal to x cubed plus ax squared plus bx plus 2. The given polynomial is already in standard form. Now the second step is to find the zeros of the given polynomial from the given factors. So the first factor is x plus 1. We will equate it to 0, and from here the 0 of this polynomial is minus 1. The other factor is x minus 2, and we will equate it to 0. So the second 0 of this polynomial is x is equal to 2. In the third step, we will write coefficients of the given polynomial. So coefficient of x cube is 1, coefficient of x square is a, coefficient of x is b, and the constant term is 2. So we will draw the synthetic division table. And on the left side, we will write the first 0 of this equation, which is x is equal to minus 1. The first coefficient is written down as it is. So we will write 1 as it is. Multiply it with the 0, which is minus 1, and write the result under the next coefficient. So 1 multiplied with minus 1 is minus 1. Perform addition of the 2. So we have a minus 1. Now we will multiply this result with the 0, which is minus 1, and we'll write the result under the next coefficient minus b. So a multiplied with minus 1 is minus a. Minus 1 multiplied with minus 1 is plus 1. We will perform addition of the 2. So we have minus a plus b plus 1. Now we will multiply this with the value of 0, which is minus 1, and we'll write the result under the constant term. So minus a multiplied with minus 1 is a, b multiplied with minus 1 is minus b, 1 multiplied with minus 1 is minus 1. We perform addition of these two terms. So we get a, we get minus b, and minus 1 plus 2 is plus 1. Now this last term is a remainder. So according to the given condition that x plus 1 is a factor of x cubed plus ax squared plus bx plus 2, so dividing this polynomial by the factor will result in a 0 remainder. So according to given condition, the value of this remainder r must equal to 0. So we can write that a minus b plus 1 should equal to 0. This is equation number 1. And from the above division, we can write the quotient value q of x after division, which will be 1 x squared plus a minus 1 x plus minus a plus b plus 1. This is the quotient which is obtained by performing the synthetic division. The polynomial has a greatest power of q, so the quotient will have a highest power 1 less than the highest power of the polynomial. So 3 minus 1 is 2. So this will be the coefficient of x square. This will be the coefficient of the next term, which is x, and this will be the constant term. Now we know that quotient is obtained when the polynomial p of x is divided by the factor x plus 1. So from here we can write that the polynomial p of x is equal to x plus 1 into qx. Now it is also given that x minus 2 is a factor of this given polynomial p of x. So this polynomial is equal to multiplication of x plus 1 into the quotient. Now as x plus 1 is not a factor of, x minus 2 is not a factor of x plus 1, means that x plus 1 cannot be divided by x minus 2. It means that this quotient q of x will be divisible by x minus 2 if it is a factor of this polynomial p of x. So for the next division by the factor x minus 2, we will consider only this quotient instead of considering the whole polynomial. So we will write the coefficients of this quotient q of x, which is 1. Coefficient of x is a minus 1, and the constant term is minus a plus b plus 1. We will draw the synthetic division table, and on the left hand side we will write the second zero of the given polynomial. Now the first coefficient is written down as it is, so we have 1. Now this one is multiplied with the 0 value, so 2 multiplied with 1, and the result will be written under the next coefficient. So 2, perform addition, a, and minus 1 plus 2 is equal to plus 1. The result is again multiplied with the 0 value of the polynomial, and the result will be written under the next term. So a multiplied with 2 is 2a, 1 multiplied with 2 is 2. Perform addition of the two terms. So 2a minus a is a, b will be written as it is, and 2 plus 1 is equal to 3. Now this is a remainder after performing the second division, and according to the given condition, and the given condition is x minus 2 is a factor of the given polynomial. So if it is a factor of the given polynomial, then the remainder a plus b plus 3 must equal to 0. So we can write a plus b plus 3 must equal to 0, and let's say this is equation number 2. Now we will perform addition of equation number 1 plus equation number 2 implies that equation number 1 is a minus b plus 1 is equal to 0. Equation number 2 is a plus b plus 3 is equal to 0. Minus b and plus b will cancel out. A plus a is 2a, and 1 plus 3 is 4 is equal to 0. So we can write that 2a is equal to minus 4, and a is equal to minus 4 by 2, means that a is equal to minus 2. So value of a is minus 2. Now we will insert a is equal to minus 2 in equation number 1. Equation number 1 is a, and for a we will insert minus 2. We have minus b, we have plus 1 is equal to 0. So minus 2 plus 1 is minus 1, minus b is equal to 0. Take b to the right hand side. We have minus 1 is equal to b, or we can write that b is equal to minus 1. So the required values of a and b are minus 2 for a and minus 1 for b. Now, instead of using these two tables for division, we can perform division in a single table. So we will write coefficients of the given polynomial, which are 1, a, b, 2. We'll draw a synthetic division table. We will write down the first 0, which is minus 1, and perform the same division. 1 multiplied with minus 1 is minus 1. Add the 2, minus a minus 1, a minus 1 multiplied with minus 1. Write the result under the next coefficient. So we have minus a plus 1. Add the 2. We have minus a plus b plus 1. Multiply it with the same 0 value and write under the next term. So minus a multiplied with minus 1 is a, minus b minus 1. Perform addition. So we have a minus b plus 1. So this is remainder number 1. Now we will perform division by the second factor, which is x is equal to 2. So write 1 down as it is. 1 multiplied with 1 is 2. Perform addition. So we have a minus 1 plus 2 is 1. A plus 1 multiplied with 2. Write the result under the next term. So we have 2a plus 2. 2a minus a is a. We are adding these two, and b written as it is, and 1 plus 2 is 3. Now this is remainder number 2. So according to the given condition, according to the given conditions, what are the conditions? That x plus 1 is a factor and x minus 2 is a factor of the given polynomial. We can write that the first remainder will be equal to 0 because x plus 1 is a factor of the given polynomial. So this is equation number 1, and a plus b plus 3 is equal to 0. This is equation number 2, and it comes from the second condition that x minus 2 is a factor of the given polynomial. So we will perform addition of the two. A cancels with a, minus b cancel with b, and we have 2a plus 4 is equal to 0, and from here we can write that a is equal to minus 2. Insert a is equal to minus 2 in equation number 2. In the previous method, we inserted the value a is equal to minus 2 in the first equation. Now let's insert it in the second equation. So in second equation for a, we will write minus 2. We have plus b. We have plus 3 is equal to 0. So b and minus 2 plus 3 is plus 1 is equal to 0, and b is equal to minus 1. So the required values are a is equal to minus 2 and b is equal to minus 1. Hopefully this is easy to understand. If you find the video helpful, please like and subscribe the channel. Thank you.